Good afternoon, dear ladies and gentlemen, and welcome to the Spatial Data Technologies for Sustainable Development conference here at MIIGAIK University in Moscow. Very warm welcome on behalf of the management of the university, present experts here and professors, and all the participants that have joined us today in online and offline formats. You are highly welcome to this keynote conference, important for sustainable development, addressing global issues, and we know that understanding the space around us is the key in further planning and further implementing those sustainable development goals as they are outlined by the United Nations. Without further ado, and not to keep you for too long, I would like to give the floor to the first speaker. This is Ms. Mihraban Kazakbekbaeva from National University of Uzbekistan, named after Mirzo Ulugbek online. Can you hear me, dear Mihraban? Maybe she's trying to connect. Now, we have the next speaker I would like to bring to the presentation table, if possible. This is Dilaria Akhmetova. She's present here. And Mihraban, as soon as you are able to connect, we will give you the floor. So now let's welcome Dilaria Akhmetova from Moscow State University of Geodesy and Cartography.
Hello. Good afternoon, dear moderator, dear participants. My name is Dilara Akhmetova, and I work at University. So today I will give a short overview of how spatial data is the urban healthcare system. And I will also talk in more detail about research.
Hello, I cannot hear any voice. The sound is too low. Does anybody can hear?
From the Laboratory of Urban Technology and Special Development in this area.
Hello, I cannot hear anything. The voice is too low, I think.
Can you hear me well now? So, to start with...
Anybody can hear me?
Yes,
Yes, I can hear you, but the sound.
Yes, we can
The
hear you.
sound of
Yes, we can hear.
the presenter is too low to hear.
Can you hear me now? Okay. Okay. So, let me continue my report. To start with, health is a universal human right and a major focus of every country's social and political concern. However, most of 55% of the world's population living in the urban area suffer inadequate housing, transport, and waste management. Moreover, such factors as noise, air, water pollution, and so-called urban heat islands, which, by the way, will be discussed by my colleague Roman later, and also the lack of space, further combine to make cities epicenters of mental and physical illnesses and drivers of climate change. That's why urban health now is the evolving area of research, policymaking, education, and practice. So, besides, urban health is in line with the United Nations Sustainable Development Goal number 11, Sustainable Cities and Communities, and goal number 3, good health and well-being. And when making decisions about the provision of urban health services, 3 guiding principles apply. The first is to provide services in an equitable way. The second and the third is to provide services efficiently and effectively. Obviously, these are questions of social and political concern. However, they are of geographical nature too, since healthcare services will have to be provided in particular points in geographical space. May you take next slide, please? Thank you. So basically, there are 4 applicational functions of spatial data, which you might see on the left of the slide. Personally, I really enjoy this functional set, as all the points here are essential. Obviously, policymakers cannot make evidence-informed decisions without qualitative and quantitative data to back it up. But visualization of data have become an integral part of modern science as well, because they make it possible to popularize dry numbers and statistics. They also make science accessible not only to the inner circle of specialists. And these functions were fully settled almost 200 years ago when this man, the man on the photo, the previous slide. When the man on the photo, called Jon Snow, who doesn't really look like the man from Game of Thrones, this man created the London cholera map. It was he who first came up with the idea that the spread of cholera is associated with water. But in order to prove his point of view to the government, he had to go around all the houses in an affected area, then compile statistics on every infected person in each house, and compare it with the location of public water pumps. In the long run, by compiling this detailed map, Jon Snow proved his point of view to the government, and the epidemics not stopped. So does this whole epidemic thing remind you of something? Yes, let's refresh our memories about COVID-19. Different measures were taken worldwide to reveal patterns in its distribution. In Moscow, there was an app created for people who got infected with COVID-19 but weren't hospitalized. It's called Social Monitoring, and it allows tracking people who violate quarantine by leaving their houses. So it is based on geospatial data and theoretically allows to identify the most infected areas of Moscow city. However, since the information of this app is supposed to be private, the application of this concrete data is unknown. So, during the pandemic, Russia, and especially Moscow, faced a problem of the lack of ambulance crew. Even before and after pandemic, there is still dissatisfaction with its work. Efficiency of ambulance services is a crucial question for urban health. So we in the laboratory came up with the idea to create our optimization algorithm for ambulance routes in urban agglomerations. This study is especially important in time-dependent emergencies, where time delay can have a significant impact on patients' survival rate. So you may see the main objectives of the study on the screen. So let's give a short overview of the methodology. To develop an algorithm, 4 methods were identified, which are displayed on the slide. Here, I should make a reservation that at the moment we have only developed a test algorithm, and only 2 methods have been used for it, with test algorithm, I mean. The data analysis and the data collection. Our test algorithm is based on the use of road graph of Moscow city, The next data to be used is points with coordinates to be visited. Well, in our study, such points are ambulance stations. So the current test algorithm has been executed on the basis on open data. However, in the future, it is planned to use more data. For example, historical data on ambulance calls, response time, and information on the nature of traffic congestions. So this data is supposed to be collected from ambulance services, traffic authorities, and other relevant sources. As for interviews and reporting, well, it is not necessary to implement them now or when we haven't actually used our algorithm, but it will still be very important in the future for decision-making in the field of urban health. So, results, the most interesting part. As a result of the algorithm work, a route with a length and travel time between all points is attained, which makes it possible to reduce the average time for waiting for ambulance. The algorithm uses a downloaded road graph from OpenStreetMap and, using the Network X library, gives flexible route settings. For example, these settings might ignore speed limitations and, as I said, make settings more flexible. Also, this algorithm allows to choose the optimal ambulance base for each call. What do I mean? So, Moscow, as you probably know, is divided in many districts. And therefore, in status quo, the choice of an ambulance station is made based on the location of the district and not on the actual location. So let's see it on the example. As you can see in the picture, for this call point, okay, it doesn't work. For this call point, it is situated in the Donskoy district. And the ambulance station that is connected with this call point to the Donskoy district is station number 1, which you can see on the left. It's the purple road. And it takes 13 minutes to get to. However, there are closer routes for this call point, stations number 14 and station number 3, which takes 11 minutes to get to. So you may think that these just 2 minutes, it doesn't make any difference. However, these 2 minutes are only shown on this example. Maybe in other situations, this difference will be more significant. So still, our hypothesis works, and summing up, the time can actually be reduced. So, in the course of this work, we can make a conclusion about the possibilities for the wide use of spatial data in the health sector, especially in urban health. And an optimization algorithm for ambulance routes is also presented, which can be used to solve several problems at once, which you may see on the screen as well. So these results may contribute to the improvement of ambulance services, and also this algorithm may be used for, well, in other logistics purposes. Thank you a lot for your attention. I will be really glad to answer your questions.
Dilara, thanks very much. This is a very interesting presentation. In fact, it's so important and hardly we can underestimate the importance of ambulance getting on time to the patients, because it's a matter of life and death, or trauma, or safe recovery. I would like to check first whether we have our experts from Thailand, Professor Saravis and Dr. Priyath, online. Can you please identify yourselves? And Prof. Gang also.
I'm here. I'm Dr. Salovit.
Excellent. I'm sure you are already making your preparations for the new year that is coming tomorrow, I believe. So in advance,
Yes.
Yes.
in advance, let's make it a year of geodesy and cartography. So the floor is open for experts to ask our dear student any questions or comments. Please welcome.
I have one question. And you use the OpenStreetMap for routing. I will ask you the cost in the link that you use for file the routing. Is you use speed limit or you use shorter distance for your algorithms?
I'm sorry, can you rephrase your question, please? I think I didn't quite caught it.
When you find the route by network analysis algorithm, the cost in the link is so important to find the way, the shortest way. I ask you that you use speed limit or use distance for finding shortest path.
Sorry, I think I have some troubles with my English because I can't quite catch the main purpose. So if you don't mind, I can answer you in the written form if you have the contacts of my scientific advisor.
Prof, can you write the question into chat? Because here we have echo and it's very difficult to hear the words clearly because the hole is quite big here. If you can write the question in the chat,
Yes.
our colleagues here will read it out and then our student can give the answer. Meanwhile, maybe experts from the panel here can have a question.
Yes, and thank you very much, Dilara, for your presentation. I'd like to ask you, is this algorithm applicable for other Russian cities, or maybe it is your results are useful for other countries or foreign cities? It is very interesting.
Thank you for your question. So actually, this concrete algorithm is based on the road graph of Moscow, but still I believe that it is applicable for other Russian cities since I think in Russian cities, we use the same basis for data collection, but I think it's only applicable for cities which are huge, not huge like Moscow, but 1 million plus cities where there is enough data to make it possible to use algorithm in a spaced way.
Thank you very much.
Any other questions or comments? Yes, please. Please speak into the mic so that our audience can also hear the question.
Yes, for someone who knows very little about geospatial data, I'd like to know how this data is applicable in real life situations where we know we have routes for ambulances, but what do we do when on a particular day there's, for example, an accident that has happened or there's a natural disaster of some sort? How is this geospatial data applicable in that kind of real life situation where something has to be done immediately? Thank you.
Thank you for your question. It is really interesting one. So as I said, right now we only have a test algorithm which is based on the data which are not which cannot be, okay, sorry. So it's based on the relevant data. However, it does not, as you said, show the real life picture. However, we are going to improve and refine our algorithm based on the more data, if we find relevant sources, so that we can actually track the traffic congestions, the number of free ambulance cars, the number of free places in hospitals. So it will be applicable in real life if we have more resources for improving our algorithm. The traffic congestion can really be shown in the real life. We will also improve the work of dispatchers, who work in the ambulance. So yes, we're going to do our best. Thank you for your question.
Thank you very much. I think we have a question now from Prof. Soravis Supavec.
Yes, here is the question in our chat. So Mr. Supavec asks you, dear Dilara, so when you find the shortest path, do you use a speed limit or a distance for finding the route? So what do you do? So when you have come to the most optimal decision, so what do you do next?
So right now we do not take into consideration the speed limits and all the information that this professor asked in his question. However, as I told, right now this test algorithm only shows the shortest route, and it can change. For example, if we have enough data about traffic congestion, but yes, it doesn't take into consideration any speed limit. And I think it will be actually a nice add to our algorithm. So thank you for your question.
Very good question. I think let's give another round of applause to our presenter here, and move on to, I want to check if Mihraban Kazakbayeva is with us online or not.
Yes.
Oh, she is. Okay, excellent. Please, you can go ahead. I believe the talk is called Preliminary Data Analysis to Create Digital Elevation Model of the Sarez Lake Area. Please upload your presentation. We are ready to see it.
Good afternoon, everyone. You can see my presentation?
Yes, we can see. Thank you.
Thank you. Good afternoon, dear experts of the conference. My name is Mihraban Kazakbayeva. I am a degree student at the National University of Uzbekistan. My short presentation is about preliminary data analysis to create a digital elevation model of the Sarez Lake area. This topic is very important for us, since the lake is located in the most safe zone. It is also one of the sources of the Amudarya River. This presentation contains project action, motivation, geodetic basic, GIS panorama, recommendation, conclusion. Next. It is known that the lake is located in the district of the mountainous Badakhshan region of Tajikistan. It formed in 1911 after a great earthquake.
Sorry to interrupt you. The presentation is not moving.
Okay, I will repeat. Just a moment, please.
Yes, I think you're going to have to click on each slide so that it appears.
Okay.
Okay, please go ahead.
It is known that the lake is located in the Rushan district of the mountainous Badakhshan region of Tajikistan. It formed in 1911 after a great earthquake when the MIIGAIK River was blocked by a big landslide. The lake also affects the water balance of the Amudera River. The length of the river is almost 1,400 kilometers. Amudera River passes through 4 countries of Central Asia, including Tajikistan, Afghanistan, Turkmenistan, and Uzbekistan. In addition, this lake and the river directly affect land reclamation, irrigation, and agriculture in these 4 countries. In 2020, the British edition of the Daily Mail also published a large article about the danger of lake areas for neighboring countries, calling the lake a time bomb. In 1999, due to the fact that the lake is located in a seismically active area, studies were carried out by international experts, as a result of which a United Nations statement was published. According to the United Nations, the risk of flooding extends from Bartan, Pianj, and Amudarya, and possibly to the Aral Sea, affecting many communities in Tajikistan, Afghanistan, Uzbekistan, Turkmenistan, and Kazakhstan. So, as you all know, a canal is currently being built in Afghanistan that will take a portion of the Amudera water. It is being dug in the north of Afghanistan. As a result of construction of this canal, it might cause water shortage in the region of the lower part of the Amudera, that is in the Bukhara, Kharazm, and Republic of Kazakhstan. This will affect a bit on the economy and ecology of the Republic. This picture shows that distance between Lake Sarias and Amudera River about 405 kilometers. Lake Sarias is the water source of the Amudera River. In spite of these problems, we are going to investigate the spatial analysis of the relief around the lake because there is a mountain rock nearby, which can collapse into the lake. As a result, the water level of the Amudera River will rise by several meters. Settlements will be flooded. For this purpose, it is necessary to study the topographic basis of the lake area with the help of a map and documents. There are several topographic maps of the region with geodetic points for G43A. There are state geodetic networks 78. Photogrammetric points are 187. Polygrammetric benchmark is only 1. These nomenclatures are for the following scales. Rectangular coordinates in the Gauss-Krüger projection and heights in the Baltic system were determined. Based on the topographic map, the length of the coastline, the area of the lake, and other parameters were determined using the GIS panorama. Currently, the area of Lake Sarias is about 80 kilometers square. The maximum length is 76 kilometers. The maximum width is 3.3 kilometers. A maximum depth of about 500 meters. And the water volume is about 70 cubic kilometers. The digital elevation model of the lake area was outside according to the SRTM, Shuttle Radar Topography mission date. It is convenient to use Google as to develop a digital model of Lake Sarias, since the area to be studied is a mountainous area. The information obtained from satellites will not be sufficient. Therefore, these data are supplemented with geodetic calculations. The used model is to identify flood risk areas and develop flood mitigation strategies. For example, building flood protection structures, relocating people living in danger zones, or providing information about the extent and severity of floods. Recommendation: it is necessary to carry out recognition of the area and points of the geodetic network, produced preliminary measurements and calculations of coordinates of points in the WGS 84 system. Explore visibility between points. Determine the area of the mountain range. I would like to thank the organizers of the conference for inviting me to participate in section 12, as well as Abdulmuminov and teacher Tarsanov for help in preparing the presentation. Thank you for your attention. I'm sorry I speak English little bit.
Thank you very much, Mihraban. Your English is perfect. We understood everything. And I'm sure now tough questions from the experts are coming in number. Colleagues from Thailand, colleagues here in Moscow, please address some questions to our presenter.
Mihraban, thank you for your presentation. I think that I suppose that your problem in your research is very important. And may I ask you only one question? Is your research include some predict model or maybe some recommendation or maybe you have some plan to research this area in the next work?
In future, we are going to work with RLC, and that's why we choose Amudarya River as our subject, and we have got some plans about our work. And thank you for your question.
Thank you.
Anyone else? All right, let's move on to the next speaker, which is also online. This is Ms. Munira Pestimirova from National University of Uzbekistan, named after Mirzo Ulugбек. The topic is geometric interpretation of Tashkent geode height for creating a dam. Please. Munira, are you with us?
Wait a little. Good afternoon. Wait a little.
Please remove the presentation, Mihraban. She's gone celebrating successful presentation. Our technical team, can we remove it? Okay.
Is it okay? Can you see?
Just give us a couple of moments. One second.
Can you see my presentation?
Not yet.
And now?
No, not yet. Ее можно принудительно включить? Mihraban, are you with us still?
Yes, yes, I'm here.
Can you switch off your presentation? Stop sharing the screen. Because oh yes, thank you.
And now? See my presentation?
Yes,
Nice.
yes, we can see it now. Please, let's start.
Good afternoon, dear experts and participants. I am Tastimiro Munira Galivna, and a graduate student of Geodesy and Geoinformatics at the National University of Uzbekistan. My presentation is about geometric interpretation of the Tashkent region haze for creating a dam. This topic is part of my master's.
We have an issue with connection there from Uzbekistan. Hopefully she will reconnect shortly. Okay. Munira, are you with us? Okay, how about we move on to the next presenter until the connection is restored. Can I invite, please, Lionel Guemjo, if I pronounced this correct? Huh? Lionel. With presentation of creation of common geospatial database model for protected areas of African continent, practical case of Republic of Cameroon. Say it again.
1, 2. Do you hear me well? It's actually Lionel Gemjo.
Lionel Gemjo.
Yes.
Okay, I got it
Thank
now.
you very much. Good day, dear members of the commission, dear fellow students. My name is Lionel Gemjo. As you know already, I'm a second-year master's degree student in the Faculty of Cartography, specifically in Cartography and Informatics at the Moscow State University of Geology and Cartography. And today I'm going to talk a little bit about creation of a common geospatial database model for protected areas with the practical case take with the Republic of Cameroon. As relevance of this project, it's important to say that the question for us here is to identify the protected areas of the African continent, classify them according to specific characteristics common to all these areas, and put them in a computerized geospatial database, which will be updated periodically to allow users of the continent, of course, foreign users, and different African governments, and various organizations in change, because we know that protected areas is something which concerns usually different organizations. And it's important to mention that we had the idea of developing a geospatial database for protected areas for the West African continent after updating the map of protected areas of the Republic of Cameroon. And in this study, it is a question of classifying protected areas by categories and showing their ratio according to the area of each region of the Republic of Cameroon, because we know that people also are very concerned to the area where they live. That's why we wanted to show also that ratio with the density of the population. In this slide, as well as we see, is shown the categories of protected areas in the Republic of Cameroon, according, of course, to the International Union for Conservation of the Nature. We have in the Republic of Cameroon natural parks, which are 19, wildlife sanctuaries, which is something special I'm going to talk about a little bit later, floral reserves, and transboundary protected areas. And in this diagram, it's shown very well that the national parks are predominant. They occupy 58% themselves. And the other part is shared almost equally by the fauna reserves, transboundary protected areas, and wildlife sanctuaries. Talking about Cameroon, it's really important to locate it, because maybe for some of you don't know really well what is about, what is the country, where is it located. That's why I wanted to show on the first map on the top left, where is Cameroon located. Actually, Cameroon occupies a strategic position in the African continent because it's located on the crossroads between West Africa and Central Africa. And it has, of course, an open path to the Atlantic Ocean, which is very beneficial for the continent. And the country is divided in 10 administrative regions. We can observe it on the map at the right side, yeah. And I also shown there the main cities. And it's important to mention that this country is specific because it has 2 capitals, one economic, one political. And the map on the left bottom shows us the density of the population by regions, and also the density of the population in the main cities of each of them. Next, talking about our main topic of today, which are protected areas. In this slide, I wanted to mention few of them for each of the categories, starting with the Wazo National Park, which is one of the most important, if I can say it, for the Republic of Cameroon, because each year, almost 1 million tourists visit this park. It's very attractive, and it's located in the far north region. It was founded in 1968. The one on the bottom, the Jar Fauna Reserve, it's specific because it's located in 3 different countries. In this case, the Republic of Cameroon, the Republic of Congo, and the Republic of Gabon. And we also have on this slide the Mbayambo Wildlife Sanctuary and the Floral Sanctuary. The sanctuary, they are actually also protected areas, but they have this specificity that practices and researches can be made in those areas by students and specialists of the field. This is the main result, of our research, which is the updated map of protected areas. Here, it's noticeable that we have new protected areas, and we classify them by colors and by categories, which are national parks, wildlife sanctuaries, fauna reserve, and transboundary. And here, we wanted to make a little innovation by comparing them with the density of the population by regions. And that gives us a clear view for suggesting to the Cameroonian government to create new protected areas in some regions. As we observe, the eastern region, we have few protected areas, but the area, it's huge, it's enormous. And also there, the climate is favorable for creating new protected areas. And this map was about that, about showing where are not protected areas and where we can create new. And now, the model of relational geospatial database. Actually, it's important also to mention that we wanted to make something really simple because protected areas are also used by people who are not from scientific field. We know that in some communities, there are people who live close to protected areas. That's why we make it really simple with few fields like the ID, the code, the official name, the type of protected areas, the region where it's located, and also the area estimation in hectares, the date of creation, the date of establishment, and also next we will add the organism or organization mainly in charge of those protected areas. This is the features of the fields in our geospatial database. In this slide, we have a prototype of the visualization of protected areas in the eastern region of the Republic of Cameroon. In the center, we can observe the map itself, which will be browsed online and which will be open sources. On the left side, we have vectors, layers, like vegetations, of course, protected areas. And in the right side, we have the attributes of the features. Yeah, it's important to mention that for realizing this prototype, we're using the GIS Quantum GIS. In Quantum GIS, it's very easy to use that software because the GIS has that specificity that they allow us to incorporate the database in them. So this is the result of the geospatial database, which will be incorporated to our map. And it's noticeable that everything that we proposed previously appear here. Next, it's also important to mention the management of those protected areas, because protected areas, they are usually enormous areas, and managing them is not something usually easy. That's why I wanted to show on this slide the institutional structure for management of protected areas in the Republic of Cameroon, which is mainly managed by different ministries, which are the Ministry of Fauna and Forest, for example, which coordinates protected areas and support to technical partners, input implements, which is also more involved in the gestion of protected areas. There are also some international organizations like the World Funds, and also the International Union for Conservation of the Nature. Yeah, on this slide, we can observe that protected areas is something really, really interesting and something which is really developing in Africa, because in 1990, there were just few protected areas which were managed by those organizations that we mentioned before. And now they increased, let's say, they doubled. Yeah, their quantity doubled. And in this slide, we wanted to show which way that project of creating a geospatial database for the world continent can be managed by different stakeholders. On the top, we wanted to show the importance of intergovernmental institutions, because they are the ones who create those protected areas, and their actions is very important. Also, we wanted to show next the complementarity of non-governmental organizations, private organizations like the World Fund, the International Union for Conservation of the Nature. And next, also, we wanted to show the contribution of local management communities. Those simple people who live close to those protected areas can also play a major role in their gestion. Of course, for managing the geospatial database, will be needed the support of GIS specialists. And for controlling all kind of traffics which can happen in those protected areas, we wanted also to show the support of the field support services, which will be simple guards. We will have camps close to those protected areas for observing and protecting those areas for every kind of traffics. In summary, this work, which is devoted to the creation of a relational database model for protected areas of the African continent based on the Republic of Cameroon, in which the representation of protected areas has been updated on the map, permitting us to create, of course, a space for classification and updating of protected areas, which recognizes each state on the African continent in a system that is open and accessible to the stakeholders concerned and the local communities. Thank you very much. I will be pleased to answer to your question.
Thanks very much, Lionel. Interesting presentation. Straight to questions. Experts. Perhaps we can invite our professors from Thailand on this international project. Colleagues?
Yes.
Yes. Okay.
For me?
Here.
Yes. So please, Mr. Pryor, go.
Okay. I'm Prayat from Thailand. So thank you for the very interesting work. And my question is, do you have a plan to put also the what you say habitation area into the map so we can know the distribution of protected area and the habitation area in the future? Do you have this plan also?
Yes, of course, because one of the most important points that I want to mention also for this work, it's to create this geospatial database also for the future generation. And obviously, we plan to release that result online and in free access.
Okay, thank you.
There was another question that I noticed. Someone asked
yes, someone
if
raised
I
their hand.
used geo packages, or I don't know if you have that question.
So yes, we have a question from Mr. Suraj Supavic, professor from Kansas University. And he asked you, Mr. Leonel, so do you use GeoPackage or RDBMS?
Well, we used both, but we chose the geo packages because they are easier to manage.
Thank you.
So thank you for your presentation. What do you think? What is the next step of your research? I mean that your database, your map is a very useful instrument for other scientific areas. For example, solving some territorial problems, or predict something, or manage of territory. What do you think about it?
Well, we actually wanted to approach different African governments because for realizing such a work like this, it needs a lot of information, of course, and some of them are hidden, they are not open. That's why we plan next to approach African governments for realizing this project.
I have a question. Do you think this technology can be used to monitor, say, these economic zones such as ECOWAS or SADC or Eastern African states at the regional level?
Yes, of course, because it's famous that some African regions, like the eastern part, is famous with the tourism. For example, in Tanzania and Kenya, there are a lot of protected areas which are famous for tourism. So I think it's even a necessity of using this technology for those sub-region part of Africa.
Excellent. So good luck.
Thank you.
Okay. Next, I would like to give the floor to PhD student from National University of Science and Technology, Engineering and Mathematics in Republic of Benin, Jules Anicet Yamonche, if I pronounced it correct.
Yes. Good morning, everybody. You pronounce it
Greetings.
very well.
I pronounce your name with English accent, but I know Benin is French speaking. So please, my apologies. My French is a bit rusty.
No problem. No problem.
Okay. Yeah, you can upload your presentation.
Okay. I'm trying to share my presentation. Can you see it? it. Can you hear me?
Yes, we can hear you. We can see the presentation. Yes.
Okay, thank you. Good day, everybody. Dear Professor.
I'm sorry to interrupt you, Professor Jules, but could you please turn the demonstration of your full screen so that your presentation would be extended in extended mode?
Okay, let me see. Full screen.
It disappeared.
Is it okay?
No, we can't see it.
Not yet. Just a few seconds.
Is it okay? Is it okay? Or should I continue without sharing the screen?
Yes, please. We can see it now, but you're going to have to click on each individual slide so that it moves.
Yes, like this,
Yeah.
like this. Okay. Thank you. First of all, I want to thank the organizer of this conference. Basically, the professor and all the people who are involved in this the organization of this conference. So, my presentation will be on the use of geospatial data for hydrological studies. Example of flood prediction and simulation of flood zone in the lower Weme Valley in Bonu, that is in Republic of Benin, West Africa. We did this work with the collaboration of Professor Dr. Biao Iboko and Dr. Musa Jibril Aliou. The outline of the presentation introduction. Secondly, we talk about the use of cartographic data, and also we talk about material and the method that we use to get our results. Then we talk about the results and discussion. And finally, we will talk about the conclusion. It is a pleasure for us to be here and sharing the experience, the research of our work, the result of our work. In recent decades, floods have become increasingly recurrent in Benin due to climate change and land use, and because of demographic increase. As you know, geospatial data, satellite map, and other constitute a basic instrument for the precision of hydraulic and civil engineering study in general. The management and the prediction of risk, disaster, water, and risk disaster. As you know, in the whole world, when there is a flood is like a catastrophe, so that it causes many damage. So to escape,
Apologies, Dr. Jules. The presentation is not moving.
it's not moving, huh?
No.
Okay. Let's see.
Try in the actual PowerPoint to click on the slides on the left side.
Okay.
Of the screen. Yeah.
Can you see the introduction now? What?
No.
Okay, let me change it. Did you see that is moving?
No, it's not moving.
Okay. There's something wrong. Let me share full screen again.
Dear Professor Jules, I
Yes.
can suggest that I turn the presentation on, and you just tell me when I should click a slide, and that's
Okay.
it. So it probably
Every time,
let's try this.
every time I will ask you. Every time I will ask you.
Okay.
Next
Yes.
slide.
And
Okay.
you just give me a sign,
Okay.
and we move on. Okay.
Okay. So you can put it on the screen. Good. Next.
Okay. So I think we may continue.
Yes. Next slide.
Next slide. Okay.
Next slide. Okay, it's good. As I said, the floods is a disaster, very bad for the whole world. And we try in this research to find a model of alarm system of precocious prevention of floods, so that we will know when the flood is starting to escape all the damage and the disaster. So in this research, we use geospatial data, and we do modeling to get some results. So geospatial data constitute a basic instrument for the precision of geotechnical, hydraulic, and civil engineering study in general. The management and prediction of risk and natural disaster. Water is a natural resource essential to life. However, failure to control the flow of a river generally leads to flooding, causing a lot of damage. In Benin, the commune of Bonu, it will focus on this research. Given to its climatic and geomorphological characteristic, it is an important area of Benin agricultural sectors. Okay, it's the river, the Wemi River, started from the western northern part of Benin, near the border of Burkina Faso, and it flows almost the 2/3 of the country, and is rejected to Nukuilak, then the Atlantic Ocean. Moreover, the lack of control over the volume of water flowing in an environment as a function of time favor the frequency of flood. It constitutes an obstacle to the implementation of preventive measures against flood. It is the context that this study focuses on the prediction of flows and the simulation of flood zone in lower valley of the Wime River at Bono. Next slide. Okay, here this slide show in upper left the situation of Republic of Benin in West Africa. It is a small country border and at the east with the big Nigeria, and also you will see in your right the River Weme and its effluents from north to south. The Weme River basin at Bonu outlets covered an area of 49,256 square kilometers and is located between 6.8 and 10.2 north latitude and 1.3 and 3.45 degree longitude. The meteorological data, daily precipitation and potential evapotranspiration data calculated according to the Penman formula, and the daily flow data used in this study covered the period from 1970 to 2015. The cartographic data used to determine the area likely to be affected by river flooding are the digital elevation model and the land use file. They are obtained from satellite image from the European Space Agency database. It is one Sentinel-2A from 2017 with a resolution of 30 meter by 30 meter. Next slide, please. So here we talk about the reconstruction of missing hydrometeorological data. We use the linear regression. The flow of the Weme River at Bonu on that T can be obtained from the flow at the Zoo River, that is an effluent of the Weme River. On the place called Dome, on that T -4, or the flow of the Weme River at Zanyalando, that is another place, another village or commune, on that T -3. That will be found on the work of Dr. Alamu and other in 2019. So I will not be going deep in the equation that you have heard here. So I will talk about the K nearest neighbor KNN. The KNN algorithm can be used for both regression and classification. Its operation can be likened to the following analogy. Tell me who your neighbor are, and I will tell you who you are. Next slide, please. So, about it, this slide will show the material and the method. We talk about the frequency analysis of maximum annual flows. According to Musi and Haji in 2003, frequency analysis is recognized as being a statistical method of prediction consisting in studying past events, characteristic of a given process in order to define the probability of its future occurrence. Thus, within the framework of this study, the most generally used distribution laws in the region is GEV, Gumbel, and log normal. These usage distribution were applied in order to determine the one that best fits the maximum annual flow data. This processing highlights important and extreme events with the probability of occurrence. That means talk about the return period. For talking about the prediction of the fluid flows. For the prediction of fluid flows, three models were used: long short-term memory (LSTM), conventional LSTM. So that means conv LSTM and random forest. Next slide, please. So this slide explain or describe each of model and also show the architecture of the LS model that is in top left. XT, which represent the input data, precipitation, evapotranspiration. YT, the predict flow rate. HT minus 1, the short-term memory of the LSTM model, which is nothing other than a copy of YT. The predicted iteration of the previous iteration. CT minus 1, the long-term memory of the network, which makes it possible to keep the information over a long period. Unlike the neural network models presented above, the conv LSTM model take as input two-dimensional data set matrix of size nxm. Okay. Here this slide show about the description of the STL model. Next slide. One of the model is random forest regression. Random forest is a widely used decision tree based method of fruit prediction. We show here the random forest algorithm. Randomly choose k data points from the set. And also we build a decision tree associated with these k data points. We choose the number of n of tree that you want to build and repeat step 1 and 2. For a new data point, make each of n tree predict the value of y for this new sample. Finally, calculate the average of the value predicted by all of the decision tree. Also, we'll talk about here you see the structure of the random forest method. About fluid simulation, the HECRAS hydraulic software, which simulated the flow of a river and estimates the expansion of water in floodplain, is used in this study. HECRAS allow to analyze the flow and the level of water in the bed of the river to determine the flood zone. Please, next slide. So here we talk about the results. This slide talk about the results of the discussion. We also reconstructed missing flow values. On the table 1, you will see the comparison of various imputation approach. The KNN algorithm overestimated the peaks, while the regression underestimated the peaks and better stimulates the average flows. The combination of the two approaches give better precision. Therefore, to reconstruct the missing flow at the given date t, we use the average approach KNN plus filter regression. So in table 2, we show the criteria for choosing the best fit. In table 3. The results of estimation of the annual maximum daily flows, Qmax, and for the return period 2.5 and 10 years. Next slide, please. So, this slide talks about the results and discussion. For flow prediction, we use 80%. For example, 1,340 data for learning train, and 20%, for example, 3,361 data for the test. The results are shown on the table 4. Table 4 shows the model performance. In the Weme River Basin at Bonu Outlet, there were former study conducted by Koja in 2018 simulate high water use in the GR4G model. Its results show an overestimation of the flows. By comparing the performance of this hydrological model, mostly used in the area, with the model based on machine learning, one can deduce that the random forest LSTM and con LSTM model allow to obtain better simulation. Next slide. So here we show on the left the map that we use, and we show the figure that gave the result of simulation of flood zone with the hydraulic model HEC RES in the lower Weme Valley. From the analysis of the result of simulation, the annual maximum flows in the study area, we can notice that the valley of Weme will be flooded. It appears that the overflow is observed along the Weme River. Figure 5 shows the expression of the Weme River overflow between August and October 2014. Next slide, please. In conclusion of this research, we will say that this research investigates the potential of using machine learning model LSTM, Conv LSTM, and random forest to simulate river flows based on the use of geospatial data. The results obtained confirm that the trained and tested model were able to achieve high accuracy and efficiency. These results represent, therefore, a new step toward the development of hydrological model based on artificial intelligence, so that's computer method, as an alternative to classical or physical models. It will be also interesting to investigate the use of deep learning models by integrating the physical character of the basin. This study also determined maximum flows corresponding to return periods of 2 and 5 and 10 years, as well as the simulation of the flood zone. Next slide. Thank you for your attention. I would like to congratulate the Russian Federation, who are celebrating this day, 12 April, the day of cosmonautic. Den cosmonautica. Ja, was очень благодарю. Spasiba za vile. Thank you for attention. Your questions are welcome, please. Thank you.
Dr. Jules, thank you very much for such a detailed presentation, and congratulations on our day of space technology, we can say. Dear experts, any questions or comments?
Thank you for your presentation. I speak it again, and now my colleagues looking at me, because in our laboratory we have the same research, and it is very interesting. I suppose that your model is very complex, and I think that it will be very interesting to have a contact and exchange our position about this problem, because in our research we use the modern geoinformational systems and visualization of data, and the question is, have you do you think is the economic model of after damage or flooding is the one of the field of your research? Maybe it will be the one of the field of your research.
Hello, can you hear me?
Yeah.
Yes, we don't focus on the economical aspects in our research about flood damage. Of course, when it is a flood, when there was a flood, it's an accident, it's a disaster, there are a lot of economic loss. But what is interesting also, you have similar research, and we are very open to continue our collaboration with our team, Dr. Yao Elezer and Dr. Musa Jibril Aliou, so for continue the research.
Okay, thank you, and I hope we can have a contract next time.
Yes, through Music Senior, I think we get contact, but I can write my email right now.
Yes, we are always in touch.
Yes,
thank you, Professor Jules.
Okay, we have Munira back online, I believe. Munira, are you with us? All right.
Yes.
Please go ahead.
And good afternoon, dear experts and participants. I am Kastamir Vamira Galievna, graduate student of Geodesy and Geoinformatics at the National University of Uzbekistan. My presentation is about geometric interpretation of the Tashkent geoid K for creating a dam. This topic is part of my master's thesis. When I was a student, then I started research on building a geoid model of Uzbekistan. Since we have not yet created this model. Of course, this is an ambitious problem, but we tried to start it. Next slide. My presentation contains introduction, methods of determining heights, gravimetric studies, development of geoid model, and conclusion. Can you see? Can you
Yes,
see
you
my
can see
presentation?
it. Yes, it's all clear. Thank you a lot.
Thank you, thank you. And introduction. The subject object is the territory of Tashkent region, which is located in the Central Asian region. Most of this area is mountainous and hill. The territory is also a seismic zone. Geodetic measurements were made at the end of the last century.
Dear Munira, I'm really sorry to interrupt you, but we cannot see your presentation. Probably there are some troubles with your connection with the internet. So probably we could do just the same as we used to do it with Mr. Yamanshi, so that I turn the presentation on and you just tell me what slide to click. Will it work okay for you? Okay, let's try this concept, okay?
And can you see?
Yes, we can see it. Okay, let's try it one more time.
And fourth slide, yes? Slide number 4.
Yes, it's all right.
And next slide, methods of determining heights. All republics have already adopted the new coordinate system. Uzbekistan has also adopted the WGS 84 system, but new topography maps have not been developed. Therefore, we ask classical topography maps. Therefore, it is necessary to make a transition to a new coordinate system. This is especially true for height. In order to develop a digital elevation model, DEM, it is necessary to perform height transformation. DEM is created based on vectorization of topographic maps. Next slide. Since 1977, all heights on topographic maps are given relative to the quasi-geoid and are commonly called normal heights. And geodetic measurements are performed relative to the geoid. One of the main geodetic applications of gravimetry is the construction of geoid models. Accurate knowledge of the geoid is necessary, in particular in navigation, direct measurements of geodetic ellipsoidal heights relative to the sea level using GPS reserves. And next slide. Gravimetric studies began with training exercise in the Tovaksla geodynamic pilot of the Bostanlık district of the Tashkent region during the 4th year of the bachelor period. In our future slides, we will show the second stage result obtained from the research, i.e., the first in the right and reverse directions, and in the second stage, the result of measurements carried out along the landfill were obtained. And next slide, based on the obtained results, scientific articles were published under the leadership of the scientific supervisor. The next plan of our presentation will be devoted to the topic of development of geoid model. Geoid heights today are determined not by surveying, but by satellite measurement. In this case, elevation map and geoid undulations are conveyed from of ancient. initial date presentation. And next slide, on the basis of such a method, in fact, measurements are carried out by different methods through satellites and through their reception on the ground. Last year's measurements results were determined through the program available on our mobile devices. Also, next slide, we can see the orientation of the pilot boundary of our selections and selected area on the topo map and matrix processed in the panoramic GIS program. A quasi-geoid model was calculated based on the geodetic height and determined by the surveying work and programs in this area. Conclusion. Based on the results of the work performed in practice, new tasks that should be implemented in the future in relation to errors and shortcomings were defined. Determination and clarification of geopotential parameters with the help of various space tools. Attraction of surface, gravimetric and geodetic data, establishing an optimal relationship between satellite observations. The volume of observations carried out by traditional Earth models. Methods. Improving determination of relative and absolute coordinate of points. The organization of this conference made it possible for us students to strengthen our knowledge of science and get in tune with the news. I would like to thank the organizers of the conference for inviting to participate in this 12th session, as well as my supervisor, Professor Mahmoud, who helped me prepare the presentation. And next slide, below is a list of reference and articles. And thank you for your attention. I speak in English a little bit. Thank you.
Thank you very much. May I kindly ask our colleagues from Thailand to comment and perhaps ask some questions? Yes, Prof, please.
Can you hear me? Yes. I will ask the, do you use leveling for compare the GNSS ellipsoid to calculate the geoorientation?
I'm sorry, can you write your question? Because I can't hear your voice very correctly. Thank you.
Whilst Prof is writing his question, can I ask maybe Professor Gang from China to participate in the discussion and perhaps the questions to our speaker here? Professor Gang? Yes.
Professor Gan, can you hear us?
we cannot hear you.
Okay, probably you could also just put your question into the chat box and Ms. Munira will give you a reply. Thank you.
Munira, please stay online. Oh yes, we have a question from the audience here.
Hello, my name is Yekaterina Kozlova, Cathedral of Geodesy, MIIGAIK. Thank you for your very interesting report. And I have a question about programs. Which programs did you use for this research? And especially for gravimetry data?
Thank you for your question. It is a very important program and a useful program, GES Panorama. And I use it, and I use it program. This program.
Mm-hmm.
And
oh, thank you. And what? Sorry.
Dr. Savaris Spovich, we are going to use this Genesis in the future.
Oh, okay. And also one question about how and when did you work with the gravimetry date? Maybe did you use copters or international date? Any resources?
Sorry, I can't hear your voice. Please, can you write it? Please.
Okay. Okay. Where did you work with gravimetry date? Maybe international resources or open resources in the internet. Maybe it was your measurements.
I open resources. I use open resources for my work in the future.
Okay, in the future. Okay, thank you.
Thank you very much. Moving on with our presentations. Can I invite Roman Kvasov, please, from Moscow State University of Geodesy and Cartography, to present his work on detection of thermal anomalies in cities. Please.
Thank you. Good afternoon. My name is Kvasov Roman. I'm a master's student in MIIGAIK, and I work in scientific and research laboratory of urban technology and spatial development. I would like you to present my research, call it detection of thermal anomalies in cities. The previous decades set several temperature records. Scientists from University College London found that an increase in air temperature by 3 degrees will lead to an increase in mortality during to the head up to 75%. Abnormally high temperatures increase the likelihood of hypertensive crises, strokes, and heart attacks. Even for a person without Crohn's disease, head is stressful. Global warming is causing various anomalies, one of which in the record head in summer. This is a big test for cities. Compared with rural areas, the temperature is in million plus cities is average 10 degrees higher. This phenomenon is called by climatologists urban heat islands. Inside the urban heat islands, the temperature is higher what is rural areas. Considering that the level of urbanization in Russia has almost reached 75% and the number of million plus cities in 16, about 110 million people, are affected by this climatic phenomenon every day. The aim of the study into assess to level of negative influence of thermal anomalies in the urban environment and to propose methods to reduce such influence. To study the causes of thermal anomalies, to study the level of influence of thermal anomalies on example of satellite image in the far infrared spectral range, analyze the results obtained and propose methods for solving the indicated problems, and to 4K research directors. As a part of the study of thermal anomalies causes and scientific publications and analysis and dialogue with these leading climatologists of Moscow State University, Mikhail Lukashenko, there conducted. The causes of thermal anomalies were clarified and their impact on the urban environment was assessed. Head islands appear for several reasons. The head balance in this city differs from the suburban one. This is due to large difference in the number and the density of anthropogenic head sources. And in addition, there in a different radiations balance in large cities, there are more activated emissions in cities due to work of enterprises, a layer of aerosol particles accumulated over populated areas. This created anti-radiation. In cities where is less heat spent on precipitation evaporation, central moisture goes into drains. The surface of open water after precipitation in cities is smaller. Precipitations quickly flow down the drains. The heat cost for the transpiration of plants are so less, that is for the absorption of water by plants and this subsequent evaporation. Among the main reasons why heat islands appear, the thermal inertia of urban surface is mentioned, such as asphalt, concrete, stone. However, they only accumulate heat and do not create it. These studied spectral images of various Russian cities taken at the end of last summer from the artificial satellite Landsat 8 and Landsat 9, specifically to study thermal anomalies, the 10 and 11 bands capture far infracted radiation or thermal infracted. They are taken Instead of measuring the air temperature, these images allow to study the air surface temperature and detect the foci of thermal anomalies. According to the values to the thermal channels, it is possible to determine the radio brightness temperature of underlying surface. Theoretically, the accuracy of the temperature estimate is about 0.5 degrees Celsius. However, the haze in the atmosphere underestimates the values by several degrees. The initial data for determining the temperature are the values of the intensity of radiation, what came to the satellite sensors and registered by corresponding thermal channel. In Moscow, plates are concreted in the southeast, south and east of the city. The hottest areas are printed and Yuzhny Portovy of the Southern Administrative District and Perova of the Eastern Administrative District. In the last, that most of Moscow industrial enterprises are concentrated. In Rostov-on-Don, a similar problem is observed. The hottest areas on the city are closer to the northwestern industrial zone and the industrial zone in the Permymatsky district. Another point in the Rostov Glavny railway station. The areas closest to the station may be hotter than the rest for two reasons. Firstly, the larger railway station in the south of Russia passes through a lot of people. There is heavy traffic around. And secondly, block of covered private houses are adjusted to it. The hottest places are areas of dense urban development. As a rule, the dense houses are built in the historical center in the city. Kazan can be example of this. Tourists who come to see Kulsharif Moscow, or went to walk from the train station to the lower Kaban Lake, inevitably far into the epicenter of the head island. It's hotter only in the north and northwest in the city. Industrial zones are concentrated there. In Krasnodar, the hottest places are shopping malls and hypermarkets. So the hypermarket of Alexander Polushkin Street heads up in the relatively cool area, free of residential development. In Kaliningrad, the location of the center of thermal anomalies showed an unexpected result. The hottest place in the city is Oktyabrski Island. There are no industrial enterprises or shopping center, train stations and garages on it. Several automobile increases pass through it. This area is adjacent to one capital territories. Once the shore of the island were stadium built for the 2018 FIFA World Cup, a lot of parking lots and paths to them they are organized near the stadium. And this concrete squares and lines are the reason for the temperature rise on Iceland. The coldest areas of the urban surface are forests and parks. There are so-called local islands of cold inside islands of heat. In forest, the valleys are consistently low due to the fact that the leaves absorb sunlight. In forest, the valleys conceivably due to fact the leaves absorb sunlight rather than reflect. In addition, the head goes to the evaporation of moisture for the leaves on plants. The industrial zones of Yekaterinburg can also be ejected to the forest, so in area Ilmash and distance 1.5 kilometers, the kilometer might differs 17 degrees. The enterprise emits head, the forest absorb it. To reduce the influence of thermal anomalies we studied, the main areas of combating head island include the following: light asphalt, white or green roofs of balance, greening of cities, and creation of additional parks. Creation of reservoirs. At the same time, in the climate of the middle zone of the north, addition head is not a problem. It may not generate head stress. For cities located in such zones, additional head saves the quality of heating cities. Every year, the problem of head islands is urgent for the cities of southern Russia and the Black Sea coast of the Caucasus, million-plus cities of the Urals and Siberia. There, the climate is sharply continental with a sharp change in temperature. May also face difficulties in summer. In these regions, the easiest way to cool building is to make roof light. The causes of thermal anomalies, as well as specific pocket of the rare occurrence, were studied. The detailed analysis revealed that factories, malls, business centers, train stations, squares, and sport complexes become the hottest spots in cities. This proves that the causes of thermal anomalies are anthropogenic factors and increased activity of the population, including created automobile traffic. To reduce the negative impact of thermal anomalies have been investigated and proposed, but this issue remains open and required additional research. The studies show what although in most of Russia there is no such eclectic issue of head in cities as in Western countries, and in the equatorial climate zone in cities this is sharply continental climate, and in southern part of the country. This issue remains relevant and requires solution. In the future, this work should help in creation of specific method and tools to combat the phenomenon urban head islands and conduct further research on the topic. Such tools shall be adapted to the conditions of the Russian climate and effectively solve the problem of health distribution. Thank you for your attention.
Thank you very much. Dear Roman, colleagues, questions, comments, maybe from the audience, please.
Thank you, Roman. You told about islands, but what about cities? In this research, did the results depend on time of year, on seasons? I can repeat. Okay. Did the results depend on seasons, on the time of year for cities?
Да, получается, снимки были изучены на момент, получается, конца лета. И для России в большинстве регионов актуально только для получается, летних сезонов.
Okay, the research is actually the most relevant for the summer season. So because the research was conducted in summer, all the cities represented here were started in summer, so it's only for summer season mostly.
Okay, but what about future? Are you going to work with this special with this specialist?
This spatial data is very special. В будущем планируется исследование по пространственным данным? На этой основе.
Да, в принципе, планируется в будущей перспективе данный алгоритм использовать как для проектирования моделей, использующих для проектирования новых районов, для оценки вероятности появления новых островов тепла, получается, которые могут возникнуть.
Yes, this research has a potential in the future because the results of the research can be used for creating the new areas and new regions, the new engineering constructions, and urban planning.
Very interesting. Good luck.
Thank you.
Okay, and now we are moving to our. We have a question, yes?
We also have a question from Mr. Gang Kiao. And the question is, how did you validate your result of temperature, heat inversion with ground truth?
Погрешность около, получается, мы высчитывали около 10-15%, получается. То есть данные передают реальную температуру земной поверхности.
Okay, Mr. Gang Kiao, Mr. Roman Kwasov tells us, well, here's the answer to your question. So the results of temperature, the heat inversion, they were validated within the geospatial software. So it registers the temperature in real time, and that's how it is validated. And we also have one more question from Mr. Sorav Supovic, Kasetsat University. And the question is, in your opinion, is the climate index El Niño and La Niña impact the research results?
В смысле, результат исследования влияет на что-то? К сожалению, этот вопрос мы не рассматривали, но вы можете отправить нам, получается, на mail, мы можем ответить поточнее на этот вопрос.
Okay, Mr. Soravis, the answer would be really, well, a detailed one, and we will send the answer as soon as possible in the most particles and all of that. Thank you. Thank you.
Thank you.
Thank you.
Now, last but not least, our final presenter, Ilya Levashov, with presentation on application aspects of network analysis in urban transport systems.
Mm-hmm. Good afternoon. Can you hear me?
Yes, we can hear you.
Yes, I'll show my display. So, no. Can you see?
Not yet.
Not yet. Strange. Because Keytalk shows me I show my special screen. Maybe I have to switch off the camera.
Mr. Levashov, we still cannot see your presentation. Well, I suggest that for more convenience and for, let's say, for fast track, we just turn on my presentation, well, your presentation on my screen, and you just tell me what to do. So you just navigate me, all right?
You've got it?
Thank you.
Okay. Do you have the presentation? Yes. Okay. I will send you that you have to change the slide. So, my name is Leva Shafilya, and I'm research associate at the Scientific and Research Laboratory of Urban Technology and Spatial Development. And the topic of my presentation was the application aspects of network analysis and urban transport system. But this is very complex topic, and it's like PhD thesis or dissertation. So yes, the actual topic will be tips and tricks in route network preparation. Next slide. The structure of my speech was three parts. First one is importance, so why it's not fundamental research, but why it's here. And the second and the third, it's tips for all-road graphs and specifically for pedestrian graphs. Next slide. So, while it may not seem fundamental, this topic is actually quite important. Errors made in data preparation and research methodology can result in accurate results, which can lead to incorrect conclusions and decisions. For example, every year, the United States economy loses about $3 trillion due to poor data quality. Next slide. And to prevent it, we have to make closer look to data quality. What about graphs? First, tips, it's connectivity. It's important to ensure that your data, your graph is connected, because disconnected graphs will prevent you from building rules between disconnected components, and you will have bad results. Next slide. How we can fix it? It depends on the software you're using. First one, if you're using Python, where is this awesomeness package that allows you to get data directly from the OpenStreetMap, and it has parameter retain all. By default, return you the largest connected component from graph. Also, there is a package called Networks that can return largest component from any graph, from OpenStreetMap or other. If you use QGIS, where is the Disconnected Islands plugin that enables you to detect any disconnected components in your graph. So you can manually connect your components or remove disconnected islands from your graph. It depends on what you need. The next slide. The second tips is difference between graph distance and real distance. What does it mean? Graph is not a spatial object, and we need to link our spatial data points from origin destination matrix. We have to link our spatial data with the graph by identifying the nearest graph node. The slide has switched off. Oh, thank you. We got a graph distance, but when we calculate it, we also need to add the distance between our spatial data, origin nodes or destination nodes, and graph. So the result distance will be sum between our graph distance and distance from spatial data to graph. The second slide, or the next slide. Also, we have to think about multiscale. What does it mean? Having a more detailed graph can yield more accurate results, but the number of edges significantly impacts computational speed. Slide switched off. Being efficient with time enables us to test more ideas and gain more insights. Therefore, two key points to consider are: first, selecting an appropriate level of detailization for your specific task, and the second one, using different scales for different tasks. For example, when you're calculating distances between settlements in a region, we need to consider just trunk, motorway, primary and secondary roads based on OpenStreetMap classification. But when we have to calculate distances between buildings, we must, in the same region, of course, we must use also tertiary roads, residential and living streets. So we have one geographic area, but we're using different networks for different tasks. It will save our time, and we will have more time for our research. The next slide. We'll talk about pedestrian navigation. We've got features like playgrounds or sports grounds that are accessible for pedestrians. We use it when we walk through the streets, but when we're using OpenStreetMap networks for pedestrian routing, where the location may be excluded because it's not line objects, it's polygon objects that are not used in navigation. To get accurate results, we need to extend the network to include this location. The next slide. So, how to fix it? There's 4 steps. First one, we will take all vertices from playground polygon, select vertices that intersects with our network. So with the entry point or exit point from network to playground, and make all possible lines between selected points. The results will append to our network. So after that, the playground is can be used in pedestrian navigation. So the next slide. As I told before, we have to link our spatial data to our graph. But after linking, after snapping, is just choosing the closer point on the graph, which is not correct, because it's may link to not in it make links with the wrong node. So we have to make pseudo entry path, and what will allows us to link our spatial data with a few nodes from graph. The next slide. So we have our origin point or destination point. We have to create pseudo nodes around the original data or original nodes, and with pseudo nodes we will snap to a network. So it will snap not in one direction but in a few directions around our point. And when our pseudo nodes are snapped, we can make pseudo edges that will be added to our network. So we can build routes from these points in different directions. The next slide. So, and the last one, we can adjust network width. What does it mean? Usually we measure distance on a plane, and it can lead to invalid results, especially on uneven terrain, and if we have a large number of stairs on a territory. When our real length is more than our plane length. In this case, it's necessary to use digital elevation models to calculate the actual length and taking into account the terrain. So yes, we have to recalculate length for every edge. The next slide, the last one. Yes, that was the tips and tricks to prepare road network. Which I think it's not the close list, but if you have any other, let's discuss. You can write me on email, on Telegram. Thank you. Any questions?
Thank you very much, Ilya. Colleagues? Questions, comments, suggestions? I think we'll leave it with the organizers, just in case there are any questions from colleagues from China and Thailand. Meanwhile, we can conclude this session and thank, first of all the presenters with these professionally done presentations, and wish you good luck in your research topics and further development. Congratulate on the upcoming new year of our colleagues in Thailand and thank them for collaboration and participation in our event. I also thank colleagues from China, experts here on the panel, all the attendees that have participated in the conference, and I think it has a good potential to expand it and invite more people. And next time, perhaps create sections for different applications of geospatial technology for sustainable development, maybe on a regional basis or technology-wise. So the floor is open for final remarks. If anyone wants to say something, please welcome.
Thank you very much for all participants of this conference. And of course, it's very pleasant to see our partners and our colleagues from Thailand. Thank you very much. And from China, I suppose that we have a lot of plans, a lot of scientific researchers, and good luck, and see you next time. Thank you very much.
Excellent.
Thank you very much. Maybe next year we will send our student to present in the conference. Thank you very much.
Yeah, that would be very good, very useful. We're waiting for them, but make sure when you send them here, give them each a big bag of mangoes from Thailand.
Okay.
We like mangoes here. Thank you very much.
Okay.
Yes, thank you all. Thank you, the participants, the speakers, and the experts of the panel board. So in a few hours, we will send you the final lists of participants and their scores and their total scores. So I will give all the instructions to the panel board in a very few minutes. So let's keep in touch. And I guess that today's evening, the winners will be determined and the awardees of the session as well. So thank you a lot. Thank you all. And looking forward to seeing you on our next conference that comes in May, again in MIIGAIK and again on spatial data, but in some other spectrum. So thank you a lot. Thank you and have a nice day.